Okay, so linear equations. First thing you want to know when dealing with linear equations is the slope. So we often use lowercase m for slope. And the slope describes how tilted a line is, what the tilt is. Okay, so a couple of ways you can think about that. You could think about that as the rise over the run. It's often described that way. Okay, and the rise means, say I've got a line like this. The rise would be if I'm going from this end of the pen to this end. How far up I'm going is the rise. How far to the right or left I'm going is the run. So the rise can be described by the difference in the y coordinates because it's the difference of the height of those two coordinates. So you could also write an equation. These are supposed to be fraction bars here. Okay, but the difference in your y's gives you the rise, and the difference in your x coordinates gives you the run. So that is the slope formula. Okay, all right. So if you have a graph, you can just count the points to find the rise and the run. But if you don't have a graph, it's probably easier just to use the formula. So I'm just going to call this x sub 1. That's my first x and my first y, and that's my second x and my second y. It doesn't really matter which one's the first one and the second one as long as you know which are the x's, which are the y's. Okay, but in my formula then, I'm subtracting the y's on top, so I'm going to do 2 minus 8. And the x's on bottom, 5 minus 3. Then I'll simplify. So I've got, let's see, negative 6 over 2. I can simplify that further to negative 3. So my slope is negative 3. A negative slope is always going to go downhill. A positive slope is going to go uphill, okay, from left to right. Okay, so here's another problem just like it. You can pause the video and try this out on your own if you like. I'm going to get straight to it. So I'm going to subtract my y's first. Negative 8 minus negative 3. So heads up, there's a double negative there. I was just using the parentheses to show, hey, it's that minus that. And then on the bottom, negative 5 minus negative 2. Okay, so in both cases, the double negative is the same as adding the positive. So then I've got negative 5 over negative 3. And I can simplify that to just 5/3 then, since it's a negative over a negative. Okay, so you want to write your slopes as a reduced fraction, or sometimes they're integers, but otherwise a reduced fraction. Okay, slope-intercept form of an equation. I had to add this in at the last second. Forgot to put it on there, but slope-intercept form is going to look like this: y equals mx plus b. M is your slope, and then the b is going to be the y-intercept, where the line crosses the y-axis. Okay. All right. So let's try out these problems. These equations happen to be in slope-intercept form, right? Because I can see the slope is the part in front of the x. The part added or subtracted to the end is the y-intercept. So on problems like this, I'm going to start with my y-intercept. Here it's 4. So 1, 2, 3, 4. It's going to cross the y-axis 4 units up. Okay. Over here, there's my y-intercept. I'll do these both at the same time. At 3, okay? And then I'm going to use the slope. So here my slope is 2/5. It's just that part in front of the x. So that means rise over run, right? I can go up 2 to the right 5 from any point on a line. On this line, I can go up 2 to the right 5 to get to another point. So I'm going to go 1, 2, 1, 2, 3, 4, 5. That grid, I know, printed out pretty light, but there it is, okay? Or actually, you could also think of this, 2/5 is equivalent to negative 2 over negative 5, so I could also go down 2 to the left 5, and sometimes that's handy to do that because you might run out of room on whatever graph you're on. If I go down 2, 1, 2, 3, 4, 5 to the left 5, get another point, and then I can graph, you actually only need 2 points, but 3 is not a bad idea, and then you just connect the dots, and you got yourself a line, and it goes on infinitely, so I'm going to put the little arrows on both ends. Okay, same kind of deal over here. Here my slope is negative 1/2, and you can either go down 1 to the right 2, or you could go up 1 to the left 2. These are all equivalent, right? So yeah, if I go down 1 to the right 2, that puts me there. Or if I went up 1 to the left 2, and then you can always, go down 1 to the right 2 again and again if you want more points. But this is more than enough. And there's this line. Okay. All right. Now taking this from a different perspective. This time we're writing an equation in slope-intercept form. So I want my equation to look like this when it's finished. Okay, so I'm going to need to know the y-intercept. Well, hey, my y-intercept is right there at -2. So the y-intercept is -2. Okay, and then the slope, what I can do is just two points that are on the grid. So I'm looking through this. And the next one that I see that's kind of an integer is right there. So then I'm just thinking, okay, let's figure out what the rise and the run are. So I'd have to go up 4 units to the right 2. So my slope then is going to be 4 over 2, which equals 2. So then I can finish this. Okay? So really you just need to figure out what these two components are. I did that here. So there's my equation. Okay, you can go ahead and try it out here. I'll try it out as well. So hey, there's my y-intercept. So b is going to equal 2, right? And then let's figure out what the m is. So I just go up 1 to the right 1. Then I got another point. So my slope is 1. Okay, so I'm thinking y equals mx plus b. The m is 1. You could write 1x, but you don't need 1x. I can see there's just 1x there, right? It's redundant to write 1x. You can just write x. And there's my solution. Okay. All right. Next up, on the next page, these same question. Let's write an equation for both of these in slope-intercept form. These actually don't really fit into slope-intercept form, but I can write an equation. So first off, the shorter of the lines is the one in these pictures. That is the one we're writing the equation for. So here, let me highlight it. We're writing an equation for these orange lines here. So these are very easy, but they're also very easy to mess up. So here's how you can just memorize which one's which. But another way you can do this if you have trouble memorizing it, just think about the points on this line. So this is the point 0, -2, right? And then I've got 1, -2, and 2, -2, 3, -2, 4, -2. All of these points, no matter which one I choose, are going to have a y-coordinate of -2, which means this is the line y equals -2. Okay, so y equals lines are horizontal. X equals lines are going to be vertical. So if you can memorize that again, that's great. But if you ever feel like you're not sure, just think about the points on that line. So, I've got -1, 0. I've got -1, 2. I've got -1, -4. All of those points have an x-coordinate of -1. Therefore, I know this is the line x equals -1. Every point on that line is an x-coordinate of -1. Okay? All right. Write the slope-intercept form of the equation of the line through the given point with the given slope. Okay, so I'm writing slope-intercept form. That is how I want my final answer in that format. And let's see what we got here. Okay, so there are a couple of different ways you can approach this. I'm going to, I know what I actually already know what the slope is, right? So if I'm thinking y equals mx plus b, I've already got the m, it was given to me. So it's going to be y equals 5x plus something, or it could be minus something because the b could be negative, okay? I have to figure out what b is though. So what I'm going to do now is I'm going to take the x and y that I have here with the through point, and I'm going to plug them into this equation. So I'm going to put 5 in for y right here, and I'm going to put -1 in for x. And now when I think about what I've got left, I can solve for b. There's only one variable in this equation. Okay, and then I want to add 5 to both sides. And b is going to equal 10. Okay, now that I know what b is, well, I can go back up here and I can rewrite that, right? So now I know that b should be 10, so y is going to equal 5x plus 10. Okay, the alternate way to do problems like this is to write your equation in point-slope form first, and then convert it into slope-intercept form. I haven't taught that yet, so I'm going to get back to that. 1 second. Right, I got distracted there. Someone came in my classroom while I was making the video. But I'm back. Okay, so let's try another of these. So I'm going to use the same method. I'm going to plug into y equals mx plus b. I can plug in the m right away. So really, it's going to be y equals negative 4x plus or minus something. Let's figure out what that something is. I'm going to plug in this x and y. So I'm plugging in 2 for y. And I'm going to plug in negative 1 for x. And then I'll solve this for b. So negative 4 times negative 1 is 4. Then I'll subtract 4 from both sides. Okay, there's my b. Yeah, and now I can rewrite this equation, right? Because I know the slope and I know the y-intercept. And there is my final answer. Okay. All right, next type of question is a little different. Now we don't know the slope right off the bat, but we do know 2 points. Okay. So if you don't know the slope, you need to find the slope. And I meant to leave a little space to talk about point-slope form. And I forgot, so I added it at the bottom here. So here is what point-slope form looks like. Looks like this. Okay, so we've got the slope again, and we've also got the x1 and y1, and that is a through point. That just means that your line is going to go through the point x sub 1, y sub 1. Okay. All right, so this time I'm going to write an equation in this format, okay, because it asked me for point-slope form, okay. All right, so let's find the slope. We need the slope. If you're not given the slope, find it. So I can do that by using the slope formula here. Okay, so I'm going to do 5 minus 3 in the numerator and 4 minus 2 in the denominator. And hey, look at that, came out to 1. So my slope is 1, okay? So now, writing an equation like this, my slope is 1. Right, so I was just using this format down right. I just plugged a 1 in there. So I actually don't even need the 1 because it doesn't do much, but I'm just going to leave it there so it's in that same format. Okay, and now I have to decide what to plug in these 2 slots. Now, which point do I use? It doesn't really matter. You could do either one because I could say, oh, this is my first x and my first y, or I could say this is my first x and my first y. It doesn't really matter. They're going to be 2 different answers, but they're going to actually be equations for the same line, so they will both be correct, okay? So that means I usually just use the first point that they give me. So I could plug in the 3 for y and the 2 for x, or you could plug in the 5 for y and the 4 for x. Again, I'm pretty much always going to use the first point, but the book uses sometimes the other one. So either one of those is fine. Okay. All right, let's try another here. You can pause the video and try it if you like. So I want to find the slope. I'm going to subtract the y's. And on top in the numerator, on bottom 2 minus negative 1 in the denominator. So I've got negative 2. That would be 2 plus 1 actually, right? Because I got a double negative. So there's my slope, okay? Now I'm going to use point-slope form. Okay, I'm going to use the first point, 0 for y. My slope is negative 2/3, and my x, I'll use -1. Okay, and you wouldn't want to leave a double negative in your answer. You probably wouldn't leave a -0 in your answer either because it doesn't do anything. So this would be a better format for that answer. Okay, or I could have plugged in the other point, right? So I could have subtracted -2, which would actually give me +2 there, right, when I write my final answer. And then for the x, I can subtract 2. Okay, so I'm just going to rewrite that into a plus. Because a double negative gives me a positive. So either of these will work. Okay. Now, if you're ever given a problem where it gives you 2 through points and asks for you to use slope-intercept form, what you could do is the same process and get down to your answer, but then you could put it in slope-intercept form. All you'd really have to do is distribute on one of these, or on this one, I'd distribute the -2/3, but then I'd also want to isolate the y. So after distributing, I'd subtract 2 from both sides. So that can work like that if they ask for slope-intercept form in that same situation. Okay, and that's it for today.